Good morning, DS4HS. Let's get into it. Now, this video is going to be very exciting because today we're going to be talking about using square brackets to extract and manipulate data from strings and lists. So let's get into it. So far, we've explored these three really important topics. Number one is the basic features of object-oriented programming in Python. And those features that we talked about are objects, names, types, attributes, and methods. Now, the second thing that we've talked about that's really important is basic Python data types, strings, integers, floats, lists. And then the third and final thing that we talked about is built-in Python functions, and we dove into these and their similarities and differences with Python method functions, also known as Python methods, and how they're associated with specific data types. So let's get into it. Now, I'm just going to click this. Now, in this video, what we're going to talk about and explore is the use of square brackets to kind of extract and manipulate the data from strings and lists. Now, what we're also going to explore is the use of parentheses with functions and the use of square brackets, and when to use parentheses and when to use square brackets. So let's get going and let's get started. Now, before we go into the hands-on stuff, let's talk about computer programming abstraction. And now, both Python string and list data types are sequences of data. That's really important to remember. They're sequences of data. Now, a Python string and list data types share the same properties from a perspective of computer abstraction. And what we mean by that is both strings and lists are sequences since they consist of an ordered collection of items. Now, for a string, what we mean by that is for a string, it consists of an ordered collection of characters. So it's just a collection of characters, ordered collection. Let's say to make a word, make a sentence, make a phrase, but it's an ordered collection of characters. Now, for a list, it's an ordered collection, but an ordered collection of data types or of items. But those items are certain data types, so it's an ordered collection of data types. So it could be an ordered collection of strings, it could be an ordered collection of strings and floats, it can be an ordered collection of integers. It's just an ordered collection of Python data types. Now, if you think about it, given that both a Python string and list is an ordered collection of items, each item in either a string or list is assigned an index number to identify its exact and precise position in the sequence. And those index numbers go from left to right. And Python index numbers begin with 0 because in Python our indexing starts with 0. We're indexing at 0. When we count, we're indexing at 1. So when we count, we say 1, 2, 3, 4, 5, 6. But in Python program, we're going to count 0, 1, 2, 3, 4, 5, 6. We start at 0. And this indexing is specified in a pair of square brackets, positioned to the immediate right of the list or string. And when we try to extract something from that list or string, we put in the square brackets. So we're saying it, hey, we want to extract data. That's what the square brackets are telling us. And then inside the square brackets, it says, what do we want to extract? And then we're going to get into that later on. But let's make this Python theory come alive by doing some of the examples below and doing some hands-on work. Now guys, like I said, if the pace ever gets too fast, you can stop the video, slow it down, go back, just go at your own pace. You don't have to feel rushed. So let's get into our first one. Now here, let's start by defining a simple string in a list of cities, names using x and y. So for x is a variable, and its value is the string Boston. Now x is a sequence of 6 characters that spell the name Boston. Yes, it is. And then y is a list of cities. So it looks like about 6 cities, and according to this, it says y is a sequence of 6 items, each of which is a Python string data type. So yep, 6 items. Each item is a string. You can tell by the quotation marks. And then we can say y is assigned to a list of strings because yep, this is a list, and now we have each of the strings. Now here, square brackets are yes to make list, but when it's a square bracket with no commas, that is most likely finding an index number. But also if the equal sign isn't there, then it's definitely an index number. For index numbers, we don't have an equal sign. But let's extract the first letter in the character sequence spelling the name city Boston. So we want to extract the first character, which is, yep, the letter B. Now, what number do you think it is? I know it says it right there, but pretend like you don't see it. Some people might say 1, but no. Remember, up here we're starting our indexing at 0. So we're starting it at 0. So what we're going to do is, like I said, start at 0. So here, the square brackets, it says we're trying to extract data from the string x, from x, which is a string. But if we don't do it with a number, boom, it's going to give us an error, invalid syntax. It's going to point saying, hey, this is blank. But we're going to want to extract the first letter, and since we're sequencing at 0, that's what, or indexing at 0, 0 is what it's going to begin with. Boom, and it gives us B, and then so on and so on. So we start with indexing at 0, so that means the first one's going to be the second letter. Okay, so this is 0, 1, 2, 3, 4, 5. So B is 0, N is 5. Now, same thing, let's extract the first item in the list of American cities. Now here, we're extracting the first item. Not the first character, just the first item. Boom, and it's New York because, like I said, for indexing, it starts at 0. So remember, when we count regular, we count 1, 2, 3, 4, 5, 6. Here we're starting at 0. So it's 0, 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4. Sorry. 0, 0, 1, 2, 3, 4, 5. But really there's 6. But since we're indexing at 0, there's 0 to 5 in the index number. And if you think about it, when you count it normally, so this would be 1 normally. If you do it minus 1, it's 0. This would be 5 normally, but minus 1, the index number is 4. So in order to find the index number, you can just subtract 1, and that's the index number. So if the regular number is 5, let's say there's 6 things, the 6th item in a list, then you just subtract it by 1, and there you go. You found the index number. Now let's try extracting with other things. Now let's extract the 4th letter in the city name Boston. So what do you think we're going to put? What do you think we're going to put to extract the 4th letter? The 4th letter is T. So what do you think we're going to put? Remember, we're starting at 0. So 0, 1, 2, 3. So we're going to put index number 3. Boom, and it's T. Now let's do the same thing with the list Y. Which one will extract the 4th letter? The 4th item, in the list of American cities. Now remember, starting at 0, 0, 1, 2, 3. Or this is the 4th item, so minus 1, 3. San Francisco. Boom. Now let's go into proof by Python. And let's introduce a new Python built-in function that you guys have not heard of yet. And that's called enumerate. And what it does is it displays 2 things. One is a precise sequence of characters in a string along with each character's index number, and it does the flip side of that for list, a precise sequence of items in a list along with each item's index number. So it's basically the same thing. For a string, it shows the characters and the character's index number, and for a list, it shows the precise sequence of items and each item's index number. But now let's check it out. So this will show every item in the sequence with its index number. So right now we're going to do X, which is a string, so it's going to show every character. So it's going to be B0, 0, 1, and it's going to show us their index number. Ready? Boom, and that's what it does. B, because it's Boston, and it says Boston's index number is 0. I mean, not Boston. The character B's index number is 0. The character O's index number is 1. The character S's index number is 2. T, 3. O, 4. And so on and so on. And now for Y, this is going to be different because it's a list, so it's not going to be characters, it's going to be items. Boom, same thing. The string New York, or the item New York, is going to give us, is related to the index number 0. The string or item Baltimore is related to the index number 1. The string or item Chicago is related to the index number 2. The string or item San Francisco is related to the index number 3. So it shows us each item or each character and the index number related or correlated with that item or character. Now, this is a syntax warning, guys, and it's really important. When to use parentheses and when to use square brackets. Now, it's really, really important, so let's check it out. Now here, we're going to generate an error message, and it's going to say syntax. It's going to be a syntax error, and we're going to read the Python error message carefully, and it's going to say string object is not callable. So let's see what it gives us. Boom, and excuse me, I was wrong. It's a type error because it's saying it's not callable, because here it's saying, are you saying X is a function? Because only functions can be called, and parentheses are used to call functions. So you only call only things that are called are functions. And with the parentheses, we're saying, hey, call x. But Python is telling us, hey, it's a type error. You got the wrong type because x is not a function. It is not a function. So if you want to extract the index number 3 from the string Boston, remember, it would be the fourth letter because we're starting at 0. B would equal 0, O would equal 1, S would equal 2, and T would equal 3. We would not use parentheses. We would use square brackets, boom, and it would give us T. But here, when we use parentheses, it's saying, hey, we're calling x a function, but Python is saying, no, that's incorrect because x is not a function. Because when you put parentheses after that, it's saying it's a function, but it's not. Okay, it is not a function. So when you put parentheses there, it's saying it's a function. With some things, it works because they are built-in functions, but x is not a built-in function. So yeah, and it's a good way to contrast between when you use square brackets and when you use parentheses. You use square brackets to extract data. You usually use parentheses for functions. So here we want to extract it instead of call a function. And plus, the reason why we got that error is because x is not a function. So now, let's determine the length of our stringer list with the len built-in function. So this is a function. That's why there's parentheses instead of square brackets. So let's check it out. So len is a cool built-in function, and it's going to show us the amount of items in a stringer list. So right here, boom, for the string Boston, B-O-S-T-O-N, has 6 characters. Now it's going to show us the amount of items in this list. So len, or length, so length of x or length of y. And let's see what it is. Boom, there are 6 items in that list if you scroll up. 1, 2, 3, 4, 5, 6. So there are 6 items in that list. And that's what len does. It shows you the length or length of a stringer list. And that's what it did here. Now, with square brackets, you can extract data from left to right, or if you want, from right to left. Now, in order to do it from left to right, you start with 0. Remember, indexing at 0. And increment up to the integer derived from the following simple math expression using len built-in function. Len x is just a variable, minus 1. Because what len does is it counts in normal terms, okay? It counts like a normal human being. It's saying Boston has 6 characters, 6 letters, because it starts at 1, 2, 3, 4, 5, 6. Goes normally. But when you're indexing, you're starting from 0. 0, 1, 2, 3, 4, 5, 6. So in order to get the correct thing, or in order to get the correct count for indexing, like with the square brackets, you can't do 6 because it only goes up to 5 since we're starting at 0. So that's why you have to do minus 1. Like I said, you can count normally, but you have to do the minus 1, and that's what it does here. And then from right to left, you can do indexing from right to left. So if you want to start at the back of it, so let's say for the word Boston, we want to get n. Instead of doing 5 in the square brackets, we could do -1 and go, and it goes and increments down or decrements down. And that's really interesting because -1 is saying the last one. 0 is the first one, -1 is the last one. -2, second to last one. -3, third to last one. -4, fourth to last one. And so on and so on. But let's do some proof by Python and check it out. So right here, we're just going to get our string Boston, and then we're just going to get our list of cities. Boom. And now, let's extract the last letter of the name Boston. So we could do, here, let me comment this out real quick. So we want to get the last string. Remember, in order to execute a cell, Shift-Enter. We could do the index number 5, okay, right here. We could do, because 0, 1, 2, 3, 4, 5. But that's a little much, all right? That's a lot of counting. So let's just do the last character. So right here, we're going to do -1, because remember, in order to go from right to left, in order to go from the back of the list or string to the front, you're going to do -1. So that's going to give us the last value. Boom. And that's exactly what it does. Now, same thing for a list. So here we have a list of cities. Boom, boom, boom. And instead of having 5 here for Seattle, because remember 0, 1, 2, 3, 4, 5. That's a lot of work and that's a lot of counting, so you could just say, hey, I just want the last item in our list, which is Seattle, and that's going to be same thing as a string, -1. Boom. And that's what we got. Now, I got to give you guys an index value warning. Python will generate an error message if your index is greater than or equal to len x, to the length of your string, the length of your list. So let's check it out. Ready? Len for x is 6. Okay. Now, read the Python error carefully. So this is 7. It's greater than 6. And it's going to say string index is out of range. So let's see. Let me uncomment it. Boom. And it says it right there. And that's the great thing about Jupyter Notebooks is it shows you where the error was. So it says the error was right here in the second line, and it says index error, string index out of range. And what it means by that is, remember, when we index it, we count from 0. So let's go to Boston again. Boston's going to be BOSTON, but B is at 0. So B equals 0, index number 0. O equals 1, S equals 2. T equals 3, and so on and so on. And it goes up to 5 because we started counting at 0, okay? So when we say 7, it's going to be like, hey, we only have 5. We only have 0, 1, 2, 3, 4, 5. So where's the 7th one? And same thing with 6. Remember up here we had to do 6, or sorry, we had to do len x minus 1, or the length of the string, length of the list minus 1, okay? So the length here, let me count it out. Comment it out and see the length again. So the length is 6. So let's say we do the length too. Boom. It's also out of range because we're only 0 through 5. Now here it says it would generate an error message if your index number is greater than len x or equal to len x. So that's one thing you got to remember. Or equal to len x. And it's the same thing for a list. So let's check it out. The length of list y is 6. Okay. Now if we do the same thing, 7 here, uncomment it out. So we're looking for the index number 7. But there's no such thing. There's only, it says 6, the length says 6 because it's counting normally from 1. 1, 2, 3, 4, 5, 6. But remember, we start at 0. So 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. That's what the index numbers are going to be like. So right here, Python's saying, hey, we have a 0, we have a 1, we have a 2, we have a 3, we have a 4, we have a 5, but we don't have a 6 or 7. So see, like right here, same thing. 6, 2, out of range. But if we do something 5, boom, it's going to give it to us. 3, boom, it's going to give it to us. So we need to find something in the index range, okay? And remember, the index is always 1 less than the length of the string or list. The index number is always 1 less than the length of a string or list. Because remember, length, the len function is counting normally from 1. 1, 2, 3, 4, 5, 6. What we're doing for index numbers counts from 0. 0, 1, 2, 3, 4, 5. Okay? And they're both 6 items. They just count differently. And I know I sound like a broken record by repeating it, but it's really, really important. And once you get the hang of it, it becomes very easy to understand. And it'll be like second nature to you. It would be like riding a bike. You'll get it. You'll know how to do it. And it will be super helpful and useful. Now let's go to something called string and list slicing. So string slicing and list slicing. Now this extracts out ranges of characters. So instead of doing one character, one item, you can do a bunch of characters or a bunch of items all at once. And now for a list or for a string, using a start and stop index range separated by a colon. So in order to extract these ranges of characters or ranges of items for a list in a list or string, you need to have a start and stop index separated by a colon. And let's go over it right now. So here, what are we doing here? Just look at it. Of course I'll go over this with you, but just try to figure it out on yourself. I know the comment helps us out, but let's just try to figure it out. Okay, here. So notice the slice starts at index 0. So we're starting with the first character because it's x. That equals to the string Boston. But ends at 3, 1, or index number 2. I don't know why this -1 is there. Let me get rid of that. Or 3. But ends at 3, or index number 2. So what that's going to do, and here, this is really, really important. So this is our start. So it means start at 0. But start including at 0. So we're going to start 0, and we're going to get 0. Okay? So 0, 1, 2, not 3. What you guys got to remember real quick is whatever you stop with here, it means exclude that. Exclude it. So it's saying stop at 3. Okay, once you get to 3, stop. Do not include 3. Stop at 3. So it's going to be 0, 1, 2. Those are the index numbers. And if you remember, X is equal to the string Boston, so B-O-S-T-O-N. So it's going to give us the first string. 0, B, 1, O, and 2, S. T is index number 3, but it's not going to give it to us because remember, it's going to stop at 3 and not include 3. So right here, boom, it's just BOS, B-O-S, because we said start at 0 and include 0, but go up to 3 and not include 3. Stop at 3. Do not include 3. So that's what it did. It included index number 0, 1, 2, but not 3. And it gave us the string BOS. And that's a really good way of extracting ranges of data. Now let's do the same thing for the list Y. Boom. And that's what it did. Here it gave us index number 0, New York, index number 1, Baltimore, and index number 2, Chicago. But it left out index number 3, which I think is San Francisco, because like it says here, include 0, but stop at and do not include 3. And that's what it did here. Now here's another format for extracting a range of data starting at 0. Now this is really interesting. So here it gives us the same thing as it did up here. Boom. But what it did is you don't have to include the 0 because here you're telling Python you're automatically starting at 0 and going all the way up to, but not including 3. So without putting a number there, you're saying, Python, the default is just start at the beginning. That's the default. And it's the same with the end, and that's what you'll see back there. So here, automatically. If you go up to 4, boom, automatically start at the beginning. And same thing. If we start here at, let's say, 2, boom, it's going to say go to the end. So if you leave that blank, it's going to say either the default is the end or the default is the beginning. So right here, we're saying the default is the beginning, go all the way up to, but not include 3. So if you don't put a number there, you're basically telling Python, I want to start at the beginning. And then same thing here, I want to start at the beginning, which is really cool stuff. Now also here, you could also start wherever you want. So I could start 2, and it's going to give me just one value because it's going to give me the index number 2, but it's going to say go up to 3, but do not include 3. Boom. So it's just going to give me S. Here, we're going to start value 1, so it's going to give us index number 1, index number 2, but stop at index number 3 and not include index number 3. So 2 items. Boom. Baltimore and Chicago. And that's really interesting. Now, you can reverse, like I said up there, you can reverse this slice method from right to left and reposition, or not reposition, but you could reposition the colon, but also depending on where you delete the number. So here we just deleted this and added a number here, or I could move the colon over here. But here we said -3. Now this is interesting. It's saying from the third to last character, go all the way to the end. Because remember, if you leave it blank on either side of the colon, you're either telling it, depending on which side, if you leave it blank on the right side, you're saying go all the way to the end. If you're leaving it blank on the left side, you're saying start all the way from the beginning. And that's what you're saying. So here we're saying -3, so the third to last, go all the way to the end. Boom. And that's what it did. Third to last letter, T, and go all the way, and it included it. So it gave us ton. And then same thing for this list. Third to last item, and then on the right of the colon is blank, so it's saying Python, just go all the way to the end. Boom. That's what it did. San Francisco, Berkeley, and Seattle. Now, here, one thing that's really cool is you can, oh, I'm sorry. Where are we? There we are. Sorry about that. You can insert functions into square brackets with one key caveat. And that caveat is that length. But right here we have it right here. So we just put length in, and we have length. And if you remember, length of x is equal to 6. So it's saying length of x equal to 6. And remember, Python is a calculator, -3. So 6 minus 3. So it's going to say 3. So it's going to equal to 3, the colon. So it's saying include everything to the end, because this is blank right here. Let's see if I'm right. Boom. Yes, it is. T-O-N. And we can adjust that, so you can do it 2, boom, just O-N. You can do 1, just N. And it's really cool because, like I said, Python is a calculator. You can insert the functions because len equals x equals a number. It's 6. If you think about it, the length of x, it is a function, but it is equal to a number because the length of x is 6. There's 6 characters in x, and same thing with y. You can do the exact same thing, and it's going to do the exact same. List of x. So list of, now this is really interesting. the function must produce an integer value for the square brackets to interpret. So if it gave us a float or a decimal, it wouldn't work. But here, it gave us an integer, and same thing, length of x. So length of this string x is equal to 6 minus 3. So starting at the third value and including that value all the way to the end. Boom. And that's what it did. To give us 3, 4, 5. And it's saying nothing was here on the right of the colon, so it's saying just go all the way to the end. Python, go all the way to the end. You can do the same thing for y. It's going to give us the same thing since the length of y is the same thing as the length of x, but it's really cool that you can insert functions into the square brackets. So yeah. Now, here's another value warning. Python sequence square brackets only accept integers. They do not accept floats. So right here, notice the error received when you use a float in the square brackets. See, string indices must be integers. Indices, excuse me, plural of an index number, say that they must be integers. So you read the Python error message carefully. Python error messages can contain good info. This error message explains string indices must be integers, so they cannot be floats. See, cannot be a float. Same thing with a list, cannot be a float. But if I change it, boom, now it's still interpreted this. Let me comment it out. Boom, give me Chicago. Let's do it up here. Boom. Let me comment this out. I'm sorry. It read that. Boom. Gave me S because this is a integer. But when you change it to a float, it gives me the error message. When you change this to a float, it's going to give you the same error message. Boom. Because it cannot be a float. It must be an integer. The only data type we'll accept is an integer. Now, exploring nesting string sequences inside of list sequences. So let's look into it. Now, len x, let's run it again, it's 6. In len x, just to review, is the function to determine the length of a string or list. Here we're determining the length of the variable x, which is assigned to the value of the string Boston, which is 6 letters, so that's why the length of x is 6. Note the length of your sequence, whether it is string or list. Now let's do len y, same thing. Now let's nest the use of the length function and find the len of y square bracket 0. So we're going to do the same thing. So here we're going to do, and as you have the instructions here, len y0. Boom. Now it's 8. Now this returns the length of the string at index 0 in the list y. Now it's New York. Now what this is saying is the reason why that was 8 is because it was saying that there are 8 characters, and yes there were. Look, N, that's a 1 character, E, 2, W, 3, space is a character, 4, Y, 5, O, 6, R, 7, K, 8. And that's what it says here. The string New York has 8 characters, including the space between New and York. And that's what we did here. We said len, and instead of doing Y, we got even more specific. We said Y index number 0. So we don't want the length of your entire list. No. We just want the length of the item at index number 0. That's what we're saying. We just want the length of New York, which is at index number 0. Now let's nest the use of the length function and find the length of y1. So let's do that. So right here we're saying the length from the list y, we're saying the length of whatever's at index 1 in the list y. So that's what we're saying here. We're saying the length of y at index number 1. That's what we're saying here. And it's nested, it means it's inside. So this index number is inside this function len. Now this should return 9, because if we go here and see what is at index number 1 for the list y, it is Baltimore. And that, if we count it, has 9 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bada bing, bada freaking boom. Now, you can extract, one thing you guys can do is you can extract and manipulate a complete sequence of items in a list or string with a Python for loop. Now, Python for loops are super important, and they make life a lot easier. For the purposes of this introductory data science notebook, we will use the following simple for loop syntax, for I in X. Now, this is very important. Where I is the index number of the string or list, X is the name of the string or list, okay? Colon is syntax used to end for the for loop. In a Python, the colon punctuation symbol is used to introduce a block of code following programmatic operations such as looping, conditional statements, if, else, if, elif, else, and function definitions. Given that we are using only the basics for loops in this notebook, the code block is on the same line as the for loop. For multi-line code blocks, following for loops, if, elif, else statements, and function definitions, all lines must be indented. But we'll get into the indentation later, and we'll talk about what this all means in the punctuation symbol of the colon. Now, more details on for loops and other notebooks will be supplied in a later notebook, but let's check them out right now. So, for I, now this is saying I is the index number mapped to each character in the string. So for I in X. So X is our actual, here X meant just some random list or string, but X is our actual string. So for I in the string X, or in Boston, print I. So it's going to say for everything in the string X, it's going to print it out. So let's see what it does. Boom. And that's exactly what it did. I went through it and it said, okay, I found the first index number. Boom, I printed B, found the second, O, third, S, T, O, N, so on and so on. Now it's going to do the exact same thing for the list. So for I in Y, so for every index number in list Y, print I. And the cool thing about this right here is you can make this whatever you want. So I can make this puppy, this name puppy, and it's still going to do it. Oh, for this one, that was interesting. Oh, because it was mapped to the index number. And it only printed I, see? But if I change it puppy here, and I do puppy, boom, Boston still. So you can make this right here, this first thing, whatever name you want it to be. So it can be puppy, it could be alpha, it could be purple, it could be your favorite season, it could be your favorite sports team, no matter what. But here, the in, now that has to be something specific. Because it's saying search for puppy or whatever, but I is a popular name for it. In a certain list, a certain string. Here, we're looking for the list, in the list Boston. Now this value has to be the same. Okay, so for puppy, or whatever you want to look for, I just named it puppy just because. In a certain list or string, in the string X, print puppy, print what we're looking for. And here we're looking for every index number. I know it can be confusing, but when you work with it a while, it's going to become more and more clear. And we're going to go into more for loops like this in later Jupyter notebooks. So don't kill yourself if you guys don't get it now. And here it does the same thing. So for I in the list Y and print everything out and print I. So it iterates through the list. So instead of saying print New York, print Baltimore, print Chicago, that's a lot of work. We can just say for I, iterate through the list Y and print everything you find. Print I. Now this is cool because it slices through this is cool because it prints or goes through, iterates through a slice of a string. So here, boom, it just said for I in X, so in the string X, but only from the indexes 1, 2, 3, stopping at 4. And that's what it did. This is index number 1, because remember, B is index number 0, O is index number 1, this is index number 2, this is index number 3, and it doesn't give us index number 4 because remember, on this side of the colon, on the right side of the colon, we stop at that number and do not include it. Print I, print everything in this slice, in this range, from the string X. Boom, same thing here. For everything in the list Y, in this range right here, starting at 1 and ending, but not including 4, print it. And that's exactly what it did. This loop through a slice of a list. Now this is interesting because this is going to say for I, so just iterate through the string X, so for I in X. So every character in X, now you're going to print it and you're going to have it dot upper. Well, that's what we're doing. We're applying a Python method for each item. So what it's going to do is it's going to print everything in this string in uppercase. Boom. Boom. That's what it did. And we did the same thing for this, for the list. It goes through everything in the list Y, and now you're going to print it dot upper. Boom. And that's exactly what it did. Now, guys, congrats on finishing that notebook. I know it was a long notebook, but it was very, very important because in this notebook, one thing we did was explore the square bracket notation as it relates to Python string and list data types. What we saw was 4 things. Python lists are delimited by square brackets and strings by quotations. Another thing was both Python strings and lists are sequences. A string is a sequence of characters, and a list is a sequence of items. Um, and the third thing we did was that both Python strings and lists have index numbers starting at 0, identifying each and every item in their respective sequence. So like I said, in order to get index numbers, we're indexing at 0, starting at 0. I know I've said this 1,000 times, but for indexing, we start by counting at 0. 0, 1, 2, 3, 4. Normally, we just count 1, 2, 3, 4, 5, but with indexing in Python, we start at 0. And the fourth and final thing is both Python strings and lists use the square bracket notation to extract specific items from their respective sequences. This process is often called slicing because we're slicing something out. We're slicing something out of the string, out of the list. And the square bracket notation with the colon allows us to not slice out one thing, but multiple things. Now our topics for our next Jupyter Notebook, and congratulations, you have hit a critical mass in your knowledge and skills of Python for data scientists. This is what a lot of people use. What we just went over is what a lot of people use. And what we've gone over is the mass, the core of Python for data science. And you'll be using these skills for the rest of your career in data science and whatever other data science course or data science project or Python course, Python project that you'll be using in the future. And these skills and these things that you've just learned, these concepts and topics that you've learned are super, super powerful. In our next Jupyter Notebook, you will see one thing and how everything you've learned in these 4 videos have prepared you to begin using powerful Python data science libraries. And these libraries are super powerful. And these data science libraries are libraries that data scientists use all the time. And what we've learned are concepts of object-oriented programming in Python, objects, names, types, attributes, and methods. The second thing was exploring basic Python data types. Remember we went over that, what's a string, integer, float, list. The third one is exploring Python built-in functions. We've gone over a lot of those. Print, sum, min, max, len, there's so many, type, etc. And then the fourth thing, comparing Python built-in functions with Python object-oriented methods or methods, and understanding the difference. And then another thing that we just went over in this notebook is exploring the Python square bracket notation with strings and lists, and the index number and indexing. Now, in our next Jupyter Notebooks and our Jupyter Notebooks in the future, we will dive directly into working with key libraries of Python for data science. And these 3 libraries, especially the first one and the third one, are very important. NumPy arrays is a key library that all data scientists use. University of California at Berkeley, Python, it's called the Data Science Library, is very important. And why that library is very important is because it's a segue, stepping stone, pathway, bridge to learning Pandas. And Pandas is probably the king daddy of them all. It's the king of them all. Very important library used by data science, computer scientists, anyone collecting data. It's pretty much the pinnacle of data science. And all these libraries will help us learn data science and also help make our job as data scientists very easy. And these 3 libraries are important, are a necessity in becoming the best data scientist you could possibly be. And I can't wait to continue our journey together. Like I said, if you guys have any questions, please shoot me an email. But thank you so much.